Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss NCERT solution for class 11th, Physics Chapter 3, Motion in a Straight Line, Part 7. And here is our welcome message. Before we begin, we request you to subscribe, like and share our channel. Please click on the subscribe button to support us and also click on the bell notification to get an uploaded updated message whenever a new video is uploaded by us. So let us begin the lesson. In the last class we have done 3.13. In today's class we'll do 3.14. So let us see the question. So the question is, a man walks on a straight road and from his home to a market 2.5 km away with a speed of 5 km per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 km per hour. What is the A magnitude of the average velocity and B average speed of man over the interval of time 1 0 to 30 minute, 2 0 to 50 minute, 3 0 to 40 minute? Note, you will appreciate from this exercise why it is better to define average speed as total path length divided by time and not the magnitude of the average velocity. You should not like to tell the third man on his return home that his average speed was 0. So let us move to our notebook. Now, time taken by the man, time taken by the man to reach market from home. Market from home. T1 is equal to 2.5 upon 5, that is 1 by 2 hour, that is 30 minutes. Time taken by the man to reach home from the market. T2 is equal to 2.5 upon 7.5, which is equal to 1 upon 3 hour, which is equal to 20 minutes. Total time taken in the whole journey is equal to 30 plus 20, which is equal to 50 minutes. Now let us find average velocity, which is equal to displacement upon time, which is equal to 2.5 upon half, which is equal to 5 kilometer per hour. This is equation 1. So now we'll find average speed. Speed is equal to distance upon time, which is equal to 2.5 upon half, which is equal to 5 kilometer per hour. Time is equal to 50 minutes, which is equal to 50 upon 60 hour, that is 5 upon 6 hours. Net displacement will be 0. Is equal to 0. Total distance is equal to 2.5 plus 2.5, that is 5 kilometer. Now we can write average velocity is equal to displacement upon time, which is equal to 0. This is the third equation. Now average speed is equal to distance upon time is equal to 5 upon 5 upon 6, which is equal to 6 kilometer per hour. This is fourth. Speed of the man is equal to 7.5 kilometer. Distance traveled in first 30 minutes. In first 30 minute is equal to 2.5 kilometer. Now distance traveled by man in the next 10 minutes from market to home in the next 10 minutes is equal to 7.5 multiplied by 10 upon 60, which is equal to 1.2 kilometer. Net displacement is equal to 2.5 minus 1.25 is equal to 1.25 kilometer. Total distance traveled is equal to 2.5 plus 1.5, that is 3.75 kilometer. Average velocity is equal to average velocity is equal to 1.25 upon 40 upon 60, that is 1.25 multiplied by 3 by 2. This is 0 0 cancel, this is 2, this is 3, so 3 by 2. So here we got 1.875 kilometer per hour. Now average speed is equal to 3.75 upon 40 60, which is equal to 5.625 kilometer per hour. And that's it. Now let us move to the next sum. Question number 3.15. The sum is in exercise 3.13 and 3.14, we have carefully distinguished between the average speed and magnitude of average velocity. So such distinction is necessary when we consider instantaneous speed and magnitude of velocity. The instantaneous speed is always equal to the magnitude of the instantaneous velocity. Why? So Instantaneous velocity instantaneous velocity is given by the first derivative of distance with respect to time. That is Vin is equal to dx upon dt. Here the time interval dt is so small that it is assumed that the particle does not change its its distance of motion or its direction of motion. As a result, both the total path length and magnitude of the displacement becomes equal to the interval of time. Therefore, instantaneous speed is always equal to instantaneous velocity. So, therefore, instantaneous speed is always equal to instantaneous velocity. Now let us move to the next question, that is question number 3.16. Look at the graph A to D and figure 23.20 carefully and state with reasons which of these cannot cannot possibly represents one dimensional motion of a particle. So these are the four graphs. Fine. Let us see one by one. 3.16. The given x upon t graph shown in A does not represent one-dimensional motion of a particle. This is because the particle cannot have two positions. So we can write the graph shown in A does not represents represents one dimensional motion one dimensional motion of the particle of the particle. This is because a particle cannot have two positions at the same time. So let us see the graph again. So here the particle could not have the same position at the two position at the same time. So one is not a two-dimensional, one-dimensional motion. So let us see the graph carefully. The second, the circle type graph. Let us see what this graph indicates. So A, this is A. The B, the second graph, the B, the given P and T graph so shown in B does not represent one dimension motion. One dimension motion because because a particle can never have a particle can never have two values of velocity at the same instant of time. At the same instance of time. So B is also not representing one dimension graph. Now let us see the graph C. So this is graph C, like a sine curve, speed and time graph. Fine. Let us check this. It does not represents represents one dimensional motion because because speed being a scalar quantity cannot be negative. Scalar quantity cannot be negative. Now D. Let us check the graph D. Okay, fine. Total. This is a total path or distance time graph. It does not represents one dimensional motion because total path length traveled by the particle traveled by the particle cannot decrease with time. Cannot decrease with time. So these are the four graphs, and none of them are one dimensional. None of them represents one dimensional motion. So this is the end of today's topic. Therefore, please subscribe, like and share this video channel. Please click on the subscribe button to support us, and also click on the bell notification whenever so that you can get an update whenever a new video is uploaded. Thank you very much for supporting us.